This lesson is for Advanced Algebra, Lesson 910, using logs and natural logs to solve equations. Students will need to use either a scientific or a graphing calculator to type in their logs. How do you know when to use this method? When the power is your variable, so if the exponent is a letter and you are trying to solve for that, you'll need to use logs in order to solve. So I've got our first example listed here. Have your calculator ready because we're going to try typing it in. I've also got the steps listed for you off to the side, so you might want to pause the video and get all this copied down so that as we go through the example you can take further notes. So the problem is to solve 10 to the what is equal to 144. Now normally 10 to a power is going to be a number like a 100 or a 1000 or a 1 million, so we wouldn't be able to figure out 10 to the what is 144 because normally a power of 10 is just going to have a bunch of zeros after the 1. So on this one we're going to want to use logs on both sides to get this x to become not an exponent anymore but a regular number. It's really hard to solve for an x when it's way up here. So what we're going to do is incorporate logs on both sides. You want to make sure, however, that the base is isolated first. There may be situations where you're working with a problem and there's something else happening to the base. So before you introduce the logs, make sure the base is isolated. If the base is isolated, go ahead and put a log on both sides. Equations are balanced, so if you do a log on one side, you have to do a log on the other side. The next piece is super important. When you're traveling from log 10 to the x to the next step, look what happens. And I did it in color here and I did it in red to try to highlight it to make it stand out. The x is no longer an exponent but a number in front. Students looked at a property in the 9-9 lesson where the exponent here can move to the front of the log. When we did that property, we did it the other direction. We had a number in front and we turned it into an exponent. But know that that property can be used in either direction. That x cannot move to the front until there's a log introduced. So it's very important that students incorporate a log into the equation on both sides and then utilize the log property to move the exponent down. That's super important because that x can't be solved for when he's way up here. Only now can we solve for x by getting the x isolated. Now that the x is isolated, I can divide both sides by the log of 10. The log of 10 is going to cancel out on this side. Not because the logs cancel, but because the log of 10 cancels itself. And then over here I'm just going to calculate log of 144 divided by the log of 10. And then I'll get a decimal answer. So let's go to our calculators next and see how you type in log of 144 divided by log of 10. So let's go to the calculator. You're going to use your log button. And so for that you do Control and then the 10 to the X button. On the Inspire calculator, you have the option to type in a base of your choosing. On the TI 83s and 84s, you are forced to use a log base 10. So if you're using a 83 or 84, just do log and then type in the number 144. On a TI Inspire, you have the option to either fill in a base of your choosing, for example, a 10, or you could simply leave it blank and the calculator will fill in a 10 for you automatically. So you can either click over to the bigger box or you can use the tab key and it'll move to the next location for you. So we're going to type in log 144 and then I'm going to hit a Control Enter there to get a decimal answer. See how the calculator filled in a 10 for me when I didn't do that? So it does that for you automatically. Then I'm going to hit the divide key. And when you hit the divide key, it should say ANS, meaning previous answer. So it's going to grab this answer plus extra decimals that are saved in the memory. And then I'm going to divide that by the log of 10. Be careful here, you can also skip over the base and just write in your 10 here. And then a Control Enter again to get a decimal answer. So you can see that it took my previous answer plus some additional decimals, and it divided it by log base 10 of 10. I had skipped over this base. It knows that I did that, so it fills in a 10 for me as the base automatically. And so I get my answer of 2.15836. So we're going to just round that to about 2.16. Now notice that the answer here was the same. If you think about that for a second, if you're doing log base 10 of 10, let's write that down and see what we get. If we do log base 10 of 10 and we write that in exponential form, let's think about that for a second. Base 10 raised to an unknown power to equal 10, well, isn't that a 1? So we ended up just doing log of 144 divided by a 1 in this case, which is why we got about 2.16. Now let's also talk about if that answer makes sense. 10 to the second power is going to be 100. 10 to the third power is going to be 1,000, which is way too big. So we know our answer is going to be somewhere between 2 and 3. And so we got an answer a little bit bigger than 2, which makes sense. So let's try another one. Let's try solving, this time a base 2 to the x equals 144. So similar numbers, but the base has changed. So I've got this one already done. We're going to do a log on both sides. As soon as the log is incorporated, the x moves to the front. As soon as the x moves to the front, I can divide both sides by the log of 2. So then let's practice typing in the log of 144 divided by the log of 2. This time I'm going to use my fraction button, and I'm going to do log of 144 on top and log of 2 on the bottom. Again, you can skip over the base. The calculator will fill in the 10 for you automatically, unless you're on an TI 83 or 84, and you're forced to put in a 10 there, or it'll put a 10 in for you. Hit a Control Enter to get a decimal answer. Get about 7.17, which is what I got. Keep in mind that when you're solving, we used a log here, but know that you could use natural log as well. The only time you should really need a natural log is if you have a log base e. So let's try solving now with natural log. If I have a base e to a power of x, and I'm trying to solve for x, if I use a natural log on both sides, look what happens. Natural log gets incorporated on both sides, the x moves to the front, and natural log of e is just a 1. So all I need to do there is type in natural log of 144 and I'll have my answer. So again, that's because the natural log of e is the number 1. Now if you forget that and decide to divide by natural log of e on both sides, it'll be okay, it'll still work. It's just you're doing an extra step that you don't need to do because you're dividing by a 1 there. But if you type that in, it absolutely does no harm whatsoever. But let's just do natural log of 144. So this time natural log of 144, and I'm going to get an answer for that. It should be about 4.96. Let's try it again though and divide it by natural log. And let's do 144, but let's divide it now by natural log of e. And if you just want it to be a plain e, you can just say e to the 1. And notice we get the same answer. So when I typed in natural log of 144 or natural log of 144 divided by e, I got the same answer in both instances. So if students don't remember that the natural log of e is 1, they can still use the same method of dividing and they'll get their answer. Before we move away from these examples to try some word problems, I just want to point out one other thing. You could utilize either a log or a natural log when you're solving. So if we did this problem again and we just changed the logs to natural logs, you would have ended up with the same answer. So let me just illustrate that real quickly by typing that in. If we do natural log of 144 divided by the natural log of 2, we should get the same answer. So again, I'm going to use my fraction. natural log of 144 on the top, natural log of 2 on the bottom, and I should get the same answer of 7.17, and I do. So know that you can use natural logs or logs base 10 or log any type of log that you wish. So the natural log and the regular log are interchangeable in this case. Most of the time we use a log base 10 because that's a nice easy button to press on the calculator, but know that natural log is another option as well. Usually we only use a natural log when we have a base e in the problem. We're going to try some word problems next. Anne invests $5,000 in an account that pays an annual interest rate of 8.1% compounded continuously. In how many years will the account have $8,000? Because of the word continuously, we know that this is going to be a PERT question or a base E question. So we're starting with $5,000, that's the P value or the starting amount. E is going to be incorporated because it's compounding continuously. I'm going to raise to the percentage. If it's growing, I'm going to keep that percent as a positive number. Just make sure you change it to a percent, to a decimal. So 0.081 is that number as a decimal. It's positive because it's paying or growing. And then the time, we don't know. We're trying to get to $8,000. So now we're going to utilize our skills from previous to the video, or at the beginning of the video. We're trying to isolate the base. The base here is base E. So this 5,000 is in our way. So I want to divide by 5,000 to get it out of the way. I'm dividing here because it's right next to the E, so that means it's currently being timesed or multiplied. So to get rid of it, I'm going to divide. So just type in 8,000 divided by 5,000, and I get about 1.6 there. And I'm left with e to the 0.081 times t, or times x. Now the base is isolated, and I'm trying to get at this t, or this exponent. So I'm going to incorporate a natural log on both sides. A regular log would also work here, but because it's a base e, it's going to be faster and easier to use a natural log to get those two to cancel. As soon as there's a natural log incorporated on both sides, the exponent moves to the front. So I'm going to have natural log of 1.6. The exponent, the number part and the letter part, moves to the front, which is convenient because now that t is a regular letter rather than an exponent. And I know that the natural log of e is going to be a 1. So I'm just going to kind of ignore the natural log of e because that's just a 1 there and I don't need that anymore. So now to get the t isolated, I would just need to divide by 0.081 on both sides. So now I'm going to type in natural log of 1.6 and then I'm going to divide it by 0.081. I don't need to divide by natural log of e. If you decide to do that, all you're doing is dividing by a 1, which is an unnecessary step. There's no harm in doing it, it's just an extra step that you don't need. So when I do that, I get about 5.8 for t. So I'd say if you round that up, that's going to be about 6 years. Let's try another one. John's college savings are invested in a bond that pays an annual interest of 6.2% compounded continuously. How long will it take for his money to triple? This is indeed, again, another PERT question, but it's a little bit different in that we're trying to get the money to triple. So it's a little bit different from the one we did above. Before we were going from 5,000 to 8,000. Now we're going from an unknown starting number to 3 times that. So let's fill in what we know for sure. We know that it's going to be a base e. We don't have a starting number. We're going to raise to the percent, change to a decimal. Got to decide if it's growing or decaying. If it's growing, it'll be positive. If it's decaying, I'll need to make it negative. And it's paying money to him. He's investing, so that should grow, so I want a positive number there. I don't know how long it'll take, so that's going to be a t, and I want my money to triple, meaning it's going to be 3 times whatever the p value is. So if I make the p value a 10, I need this number to be a 30. So I don't want to make up numbers here. I just know that if this is a 1, this is going to be 3 times as much. So the triple there is what I want to make it equal to, and I make my p a 1. So now I'm going to solve that using my knowledge or my skills with logs. The base is already isolated. I don't have a p-value here that I have to get rid of. The principal amount is simply a 1, so I'm going to incorporate natural logs on both sides as my first step. I'm just going to slide that 3 over a little bit. So if I incorporate a natural log on both sides, in my next step, the power moves to the front. And that's the whole point of incorporating a log, is because it allows us to manipulate that exponent and turn it into a regular letter. Now the natural log of e is a 1. I could divide both sides by natural log of e, but that's the same as dividing by a 1, which I don't need to do. So I'm just going to simply ignore natural log of e. To get the t isolated, I need to divide by the number next to it, 0.062. So I'm going to type in on my calculator natural log of 3 divided by 0.062, and I'll have my answer for my time, which in this case is about 17.7. So it's going to take 18 years for the money to triple, if I round that number up. And then our last example is number 11 in the homework. It's very similar to the two we just did. Just want to give you one final chance at practicing, and it's going to help you get your homework done a little faster. So let's read this final example. Suppose you invest $250 in a savings account, paying 3.25% interest compounded continuously. How long will it take for your account to grow to $300, assuming that no other deposits or withdrawals are made? So our starting amount, our p-value, is 250. I know it's going to be a PERT question because it's compounded continuously. If we didn't use the continuously word in the problem, we would just be using ab to the x. We're going to raise to an account that's paying, meaning it's a positive interest. So this number is going to be positive r. Change it to a decimal first. So if I move the decimal point 2 places, it's 0.0325. I don't know how long it takes, so that's my time, my variable, my t, and I'm trying to get to the number 300. So this one's like the first one that we did today, the first word problem. I need to isolate the e, so that 250 needs to move out of the way. Because it's being multiplied right now, I'm going to divide to get rid of it. Whatever you do on one side, you have to do on the other because equations are balanced. On this side, the e, I'm just going to rewrite what I have. Over here, I'm going to calculate 300 divided by 250, and I get 1.2 there. As soon as the e is isolated, meaning nothing else is in front of it, I can incorporate a natural log. Again, I'm using natural log because it's a base e. If I decided to use a regular log, it would still work, but it would add an extra step to my stuff, so I'd rather not do that. As soon as the natural log is incorporated, this exponent now can move to the front. So 0.0325t goes in front of natural log of e. That's a really crucial step because if we don't move it to the front, we can't solve for that exponent. Natural log of e is a 1, so I'm going to ignore that piece. To get the t alone here, I would just divide by 0.0325 on both sides. So you type in natural log of 1.2 divided by 0.0325, and you'll have your time that you're looking for. In this case, about 5.6.